Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 8, Section 6 with you. This is our last section of the chapter, and it's all about vectors. And there's some terminology here. You can see here with the vocab, there are a lot of different words to help us describe and define vectors and parts of vectors and things like that. In the most basic form, when you talk about a vector, you're talking really about an arrow. And it has a starting point and an ending point. If you look at this right here, this picture, we have point A as the initial point, and we have our terminal point, which is our end point, and there's a little arrowhead here. And we can call this vector AB with a little arrow over it, or sometimes you'll see it as just a lowercase letter v with the vector. And we have this is component form of a vector. We can also name the vector using component form. Basically what you're doing is it almost looks like a point, x comma y. And what that indicates really is your horizontal change and your vertical change. So in component form, we would talk about a vector CD, we would talk about this as being 2 comma 3. So from C, wherever you are on the coordinate system here, you're going to move over 2 and you're going to go up 3. And so the first example here is just practicing using vectors in component form. We have vector EF, which is listed here, and if you notice here, we're moving 1, 2, 3, 4 units to the right, so that would be a positive 4 direction. And then we're moving 1, 2, 3 units down, and so our component form would be 4 comma negative 3. Again, it looks like a point, but it's not really a point. It's indicating a vector. This next example, they're just giving us a couple of points P and Q, and we want to find the component form here. And if you're given the points like this, the easiest way to do this is to subtract 4 minus 7 and then 3 minus a negative 5. Two negatives will make it a positive, and then this is my component form here. Just be sure that you go in that order from the ending point, the Q point in this case, and we're subtracting the P point. And that would be our initial or our component form of that vector. And we can use vectors a lot of different ways, and they can tell us a lot of different things depending upon what you're using them for. One of the things that you talk about when you deal with vectors is something called magnitude. And the magnitude is written like this. It looks like absolute value lines around vector AB or vector V. And here is where the distance formula basically comes in. If you are drawing a vector out 4 comma negative 2, what you can do is start the vector at the origin at 0, 0, and then go over 4 and down 2, and then to find the magnitude, you can use the distance formula. The distance formula was something that we've talked about before in the past, and if you take the square root of 20, you get 4.5. So what that is indicating is that the length of this vector right here is 4.5. And you know, we've done some of that stuff just with different examples that we've done in the past. We're just talking about it now in terms of a vector. The direction of a vector then is an angle that it makes with the horizontal line. So in this case, we have a couple of examples here. In this case, our horizontal line is here, and we're going up 60 degrees. And so we would say that the direction of vector AB is 60 degrees. You can also talk about a vector in terms of a direction, such as north, south, east, west. And a lot of times you'll see this as a bearing. This would indicate here going north and then 30 degrees towards the east. So it would be written like this: n 30 degrees E would mean that we start north and then we're going 30 degrees towards the east, and that would be where our vector would lie. In this example here, This is a good application problem here. Wind velocity is given by the vector 2, 5. Again, start the vector at the origin, go over 2, up 5. We draw the vector, and then find the direction of the vector to the nearest degree. And so this is where we end up with our trig functions, our triangles that we talk about. The easiest one to use here is tangent. We're trying to find that angle right in there, and so I would take tangent of my angle, A, is equal to 5 divided by 2. Again, use the inverse tangent button on your calculator, and you should be able to find that angle. Then we have a couple of other terms here. Two vectors are equal vectors if they have the same magnitude and the same direction. Okay, same magnitude, same direction. Two vectors are parallel if they have the same direction or if they have opposite directions. So you can see here, these would be parallel as well as these here would be parallel, even though they're going the opposite direction. And then we have an example here just showing you kind of labeling equal vectors and parallel vectors. When we talk about the resultant vector, now what we're doing is actually adding two vectors together. And you can kind of draw this out where we have vector u is the first vector, and then we go up vector v this way. The resultant vector is going to be this green vector right here. This is vector u plus v. Sometimes what they'll do is, this is called the head to tail method, so that the head of the first vector and the tail of the second vector just get connected, and your resultant vector is here. Another way that they'll talk about it is a parallelogram, and they'll actually draw out a parallelogram. They'll connect the two tails right here, and then draw a nice parallelogram, and then your diagonal is your resultant vector. Either way is fine. It kind of just depends on what you feel. Basically, this part here, if you have vector u and vector v, then u plus v will just be the sum of the x values and the sum of the y values. Again, there are lots of different examples that you can go through and talk about different kinds of vectors. A lot of times in science or in physics, things like that, you'll see a lot of vector problems. If you have any questions, please let me know. Thanks.